Good afternoon. So this is the basic setup or arrangement for the PN junction diode characteristics. So these are the main major equipment that we are going to use for this experiment. So basically in this experiment we are going to take the characteristics between voltage and current for the given diode. So this is your diode which is connected as per the circuit diagram. So this is the regulated power supply, and from this regulated power supply whatever the voltage that are supposed to supply for the circuit, that will be provided by the RPS, regulated power supply. So from that we are going to measure how much voltage obtained from the diode and how much current that is produced by the diode, that we are going to take with respect to this voltmeter and ammeter. So firstly we will apply some voltage to the diode. So here if you can observe here, the diode is connected in series with the resistor. Because this resistor opposes some voltage, so it will protect the diode. Okay. Then the remaining voltage will be supplied to the diode. So then whatever the voltage that is supplied to the diode, based on the voltage we have given to the diode, the corresponding current will be produced at the ammeter. So here this is ammeter which measures the current that is measured in milliamperes. Okay. So first of all, coming to this experiment, basically the diode can be accessed switch, means that is on and off. So once the coming to the diode characteristics, it will works on forward bias and reverse bias. So in the forward bias, the diode is connected, the polarity of the diode is connected to the positive polarity of the regulated power supply, and the negative polarity of the diode is connected to the negative polarity of the RPS. So then we can call it as a forward biased. So we know that in forward bias the diode can be accessed on switch, means the diode conduct. So once the diode conduct means whatever the voltage we supplied to the diode, the same voltage, for the same voltage the corresponding current will be calculated in ammeter. Okay. So once the diode is connected in reverse bias, the diode gets off, means the diode does not conduct, means the diode becomes open circuited. Okay. So in that situation the diode becomes open circuited, means the current will be zero. Okay. So but here, because in reverse bias some minority carriers are there, so due to the minority carrier recombination some minor current will produced, so that is nothing but leakage current. So that leakage current is calculated in this ammeter. Okay. So then we will take the with the help of that readings we will obtain the forward bias and reverse bias characteristics. So firstly, if you can observe here, the voltage versus current VI character, this is nothing but VI characteristics, means the relation between voltage and current. Okay. So first of all, for the forward bias we will apply the forward voltage versus forward current. For the reverse bias characteristics we will apply the reverse voltage versus reverse current, we will calculate. Okay. So this is the experimental setup. So for the connections point of view, first of all, from the regulated power supply we will give the connection to the resistor, a series resistor which is connected before a diode. Okay. So from the resistor we are using this diode connected to the diode. So from the diode to the negative terminal of the RPS, and the voltmeter, we know that every time the voltmeter is connected in parallel to the diode, and the ammeter is connected in series with the diode. So because in series the current is same, in parallel the voltage is same. So with this setup we are going to perform the PN junction diode characteristics in forward bias and reverse bias. So the rest of the readings will be take later. So this is the main setup and arrangement and the procedure we have to follow while you are going to perform this experiment. Okay. So coming to the forward bias characteristics. So here the diode is connected in forward bias. So with respect to the potential voltage we are applying with respect to the regulated power supply. So first of all, coming to the procedure for the forward bias characteristics. So by applying the voltage from the regulated power supply, so with respect to the resistance what we have connected here, the remaining voltage will be supplied to the diode. So corresponding voltage, because of the corresponding applied voltage, okay, the voltage across the diode, the current will be measured at the ammeter. Okay, so first of all, by changing by varying the voltage, so while you are adjusting the regulated power supply voltage till some particular voltage, the current will be becomes zero, because we know that the depletion region is there. Because of the depletion region of the diode, the current will not be produced in the beginning. But later, after some voltage we have applied, due to the cut-in voltage, the current will starts conducting. The current starts conducting, so that slowly, if you can observe this, the current is gradually changing from its initial position. Okay, so this is the forward biasing procedure. Initially, what is cut-in voltage? Cut-in voltage is nothing but at what voltage level the diode starts its conduction. Means because the diode initially off position, later after applying of some particular voltage, whatever the depletion region is there, that will be vanished. So then the diode starts its conduction, so that the current will gradually increases up to some 30 milliampere and 40 milliamperes. So here, if you can observe here, we are applying the maximum voltage 30 volts. So, but this 30 volts is not directly applied to the diode. This diode will actually takes only some 0.5 or 0.6 or 0.7 voltage, because this 0.5 and 0.6 is the cut-in voltage. Means at what voltage the diode starts its conduction of current, that is nothing but cut-in voltage. So actually in this procedure we have to observe these two meters. One is the voltage across the diode, the current through diode. The voltage across the diode and the current through diode. This is the voltage, applied voltage. So here we need not to bother about the applied voltage. We have to focus on the voltage across the diode and the current through diode. So this is how we are increasing the voltage. So if you can observe here, as the voltage, if you can observe here, as the voltage is increasing till some particular 0.5, the current is 0. But after increasing, after 0.5 volts, if you can observe here this meter, the current starts, the needle get deflected. So that means the current starts rising. Okay. So this is how we can observe the cut-in voltage of the diode. Generally, the diode cut-in voltage, it depends upon the material what we are using. If it is a germanium or it is a silicon material. Okay, depends upon the different materials, the diode cut-in voltage will varies. Okay, so this is how we are going to measure the diode characteristics, means the relation between voltage and current. How much voltage we are applying to the diode and how much current is producing. So this is the VI characteristics of PN junction diode in forward bias. Coming to the procedure for reverse bias characteristics, if you can observe here, the polarity is changed. The diode anode and cathode are interchanged. So that is now the diode is in the reverse bias with respect to the regulated power supply. So in the reverse bias, the diode is supposed to be off, but due to the minority charge carriers are there. So due to the minority charge carriers, they are migrating from P region to N region and N region to P region. So still some current will causes. So that is nothing but the minority current or leakage current. So this is just exactly like the procedure of PN junction diode forward bias, but the current which causes in the reverse bias is due to the minority carriers. In earlier case, the whatever the current we cause that is caused in the forward bias, that is due to the majority charge carriers. Okay, here by applying the voltage across the diode, by applying the voltage, then some current will be the voltage will be increasing. This is the voltage, reverse voltage we are applying. So due to this reverse voltage, the reverse current is gradually increases. Okay, so if you can observe here we are using a microammeter because the current which producing in reverse bias is very less current while we are comparing with the majority carriers current. So that is the reason to identify or to observe the changes we are using the microammeter instead of a milliammeter here. The remaining procedure is as usual. While increasing the voltage, applied voltage, some voltage, reverse voltage is appearing across the diode. Due to that voltage, the current, the minority current causes, that current will be observed on this microammeter. Thank you.